This is Xiphactinus, also pronounced Xiphactinus.
Helicoprion was a huge cartilaginous fish.
This is the biggest complete specimen of Xiphactinus.
A lot of people wonder what the name Xiphactinus means.
3 fossils, 3 bad decisions. 1 sliced giants, 1 swallowed dinner whole, 1 sported a spiral saw. From cliffs to museums, these predators rewired oceans after disaster. No capes, just questionable table manners. Buried in desert rock, a giant sea hunter waited for its story to surface. Bones hinted at something bold, an early ruler of the waves with teeth made for slicing. The trail ran from Nevada cliffs to a Chicago museum and toward a question. How fast did oceans recover afterwards? Meet Thalattoarchon saurophagis, whose name means ruler of the seas, lizard eater. It lived in the Middle Triassic, late Anisian age, about 244.6 million years ago. Its bones came from the Taylori zone in the Fossil Hill, member of the Favorite Formation, at Favorite Canyon in the Augusta Mountains, Pershing County, United States of America. The holotype catalogue number FMNH-PR 3032 rests at the Field Museum of Natural History. The first eyes on the skeleton in the field were those of Jim Holstein on July 24, 1998. After careful return work, the team collected the specimen in 2008 and the formal description appeared in the Proceedings of the National Academy of Sciences in 2013, authored by N.B. Frobisch, J. Frobisch, P.M. Sander, L. Schmitz, and O. Riepel. What was found is a partial skeleton with much of the skull, parts of the backbone, and pieces of the hips and hind fins. The snout tip is gone, which is rude, but there is still plenty to read. This animal stretched beyond 8.6 meters in length, about 28 feet, and carried a big head for its body size. The teeth are the real headline. Laterally flattened crowns with 2 sharp cutting edges and no serrations. One preserved tooth stands about 12 centimeters tall, with a crown roughly 5 centimeters. Those are not salad forks. They are tools for slicing big prey. Scientists call it a macropredator. It hunted large fishes and marine reptiles, maybe even animals close to its own size. Think of the role of modern killer whales. Only swap the sleek black and white for a Triassic powerhouse. Its presence so soon after the end Permian mass extinction shows ocean food webs rebuilt faster than many might expect. On the family tree it sits more advanced than Mixosauridae and the big fellow Symbospondylus, with a skull nearly twice as large for a similar body length, and it differs from Himalayasaurus by lacking fluted tooth surfaces. The original analyses placed it within Merariamosauria near the base, which helps map how early ichthyosaurs grew into top spots in the sea. Public stories helped this fossil travel far. A Field Museum blog unpacked the discovery. National Geographic told the tale with art by Raoul Martin, and Live Science shared field photos from Favorite Canyon. Even Mindat keeps locality notes. For a fossil that once slept in desert stone, it has had quite a busy afterlife. No cape, no crown, just serious teeth and a very big job. Meet Xiphactinus audax. This was not your friendly reef fish. It was a giant, fast, mouth-first hunter from the deep past. Fossils show drama, mystery, and a few poor life choices. One famous skeleton even reveals a last meal that was a little too ambitious for comfort. The story of Xiphactinus audax begins with its name, coined by Leidy in 1870. A year later, Cope introduced Portheus molossus, which later turned out to be the same animal. Scientists placed this fish within Actinopterygii, Teleostei, the order Ichthyodectiformes, and the family Ichthyodectidae. Think sleek body, huge head, and long fins built for quick lunges. It ruled the Late Cretaceous, especially the Western Interior Seaway that split North America. The best bones come from the Niobrara chalk, especially the Smoky Hill chalk member of Kansas. The range stretches north to Alberta in the Pusquascow Formation, and the genus shows up in Europe, Venezuela, and Argentina. Material once called Portheus in Australia is now placed in the related Ichthyodectid Kuyu. What did it look like? Picture a torpedo with teeth. The jaws held smooth conical spikes set in sockets. The body was laterally thin, with a tall dorsal fin and a forked tail. Adults reached about 5 meters, and models often use 5.1 meters for testing. Some sources boast 6 meters, but rock-solid evidence is rare. The most famous fossil sits at the Sternberg Museum of Natural History in Hayes. Discovered by George F. Sternberg in 1952, it is the legendary fish within a fish. Inside the ribcage of a large hunter rests a whole Gylicus arcuatus nearly 1.9 meters long, swallowed by a predator around 4.2 meters. It likely caused a fatal internal problem. Turns out even ancient giants learned that your eyes are bigger than your stomach is not medical advice. Teeth tell us it ate big, slippery prey, and bite marks link it to the large lamniform shark Cretoxiorina mantelli. Sometimes the shark seems to have had Xiphactinus for dinner, and sometimes the other way around. Juvenile fossils are scarce, but small jaw pieces show sharp teeth early in life. No baby food phase here. A study in 2020 suggested regional endothermy, which means parts of its body may have stayed warm for strong, sustained swimming. That would help explain its widespread and active lifestyle in open water. You can see striking skeletons at the American Museum of Natural History and the University of Kansas Natural History Museum. In chalk beds, these fossils rest with marine reptiles, sharks and seabirds, drawing a vivid picture of a crowded sea. In short, Xiphactinus audax was a bold, toothy teleost that sprinted through ancient seas, swallowed big meals, and left behind fossils that read like action scenes. It teaches clear lessons about evolution, appetite, and why pacing yourself is not just for running, but for eating too. Deep in the Permian seas swam a hunter with a spiral secret. Meet Helicoprion, the fish with a tooth whorl that grew like a rolled saw. For decades, no one could place that spiral. Then, in 2013, careful computed tomography finally unlocked its jaw, and the puzzle turned thrilling for scientists. It was not a true shark, but an eugeneodont, a stem holocephalan related to chimeras, also called ratfish. The tooth whorl sat along the midline of the lower jaw, supported by a labial cartilage and filling Meckel's cartilage. The jaw used autodiastylic suspension, with the higher mandibular not part of the joint. In Idaho, a remarkable jaw with spiral teeth was found in the Phosphoria Formation. The Idaho Museum of Natural History specimen, IMNH 37899, nicknamed Idaho 4, preserved upper and lower jaws together. Tapanila and colleagues scanned it with computed tomography and reported the results in Biology Letters in 2013. Helicoprion lived from the Artinskian to the Rhodian, about 290 to 272 million years ago. Fossils turn up across Russia, the Urals, Western Australia, China, Kazakhstan, Japan, Laos, Norway, Canada, Mexico, and the United States. From Nevada and Wyoming to Texas, Utah, California, and yes, more Idaho. How did that spiral work? Modeling by Ramsey and others in 2015 suggests the front teeth hooked prey, the middle teeth pierced, and the rear teeth pushed and cut deeper as the jaw closed, a sawing transport cycle. Estimated bite forces range from 1,200 to 4,700 newtons. Squid would not send thank you notes. Many scientists think it hunted soft-bodied cephalopods. The whorl and the upper jaws may have made a three-point contact that helped pull flesh from ammonoids and nautiloids. It sounds grim, but it is just lunch in the ocean. The whorl carried more than 100 serrated teeth. New teeth grew at the center and pushed older teeth outward. The structure filled the length of the lower jaw. Most of the skeleton was cartilage and did not fossilize well, so jaws and teeth still dominate the record, which explains the many wild drawings over the years. How big was it? Using whorl size, many estimates land around 6 to 8 meters or 20 to 25 feet. Some claim larger beasts, but methods differ. Tapanila and team discussed limits in 2020 in The Anatomical Record, and Gayford and colleagues in 2024 warned that scaling tricks can overshoot. A careful morphometric study by Tapanila and Pruitt in 2017 in the Journal of Paleontology supported 3 valid species: Helicoprion davisi as the type and common in Idaho, Helicoprion bessonovi in the Urals and Kazakhstan with records in Japan, and Helicoprion ergasaminon, rare and known from Idaho. For years, artists placed the spiral on the snout, the throat, even the tail. The computed tomography study anchored it in the lower jaw and tied Helicoprion to chimeras. A well-kept Wikipedia page gathers sources, but many mysteries remain. We still lack a whole skeleton. That keeps the story lively.